Welcome to Linked Data Engineering. This is lecture number 2, RDF and RDFS. And in this part of the lecture, I'm going to tell you more about the turtle serialization of RDF. RDF is the resource description framework, and it's used in the semantic web or linked data technology stack to exchange information. So, let's go back to an already known example. We have here Pluto, which has been discovered in 1930. And we have Pluto, which has the discoverer Clyde Tombaugh. So in the upper part of the slide, you see the graph representation of that fact. And in the lower part, you see N-triple representation. The N-triple representation, as we have already told you, is the most simple representation there. So you see, starting with N-triples, you can directly transform these facts into turtle, into the terse RDF triple language, which is quite simple or quite handy. So what you can do here, for example, is for means of abbreviation. We have already talked about that. You can define prefixes. So with the prefix directive, which is part of the turtle language for RDF, you associate a prefix label with an URI. As you see here, we have the prefix label DBO defined in the first line of the example, and then we use it in the third and the fourth line, together with a relative URI. Another means of abbreviation is, for example, the definition of a base directive, which provides a URI to complement all relative URIs which are not let in or complemented by an already existing or defined prefix. So every relative URI that is encountered will be complemented with the base URI that has been defined in the base directive, as you see here. So these are the first two means to abbreviate the facts that have been represented in RDF. But as you see here, there is still some redundancy in the code. So in line 3 and 4, both times we have to repeat the subject, so Pluto comes here twice. This, of course, is redundant. And Turtle, of course, provides some means to get ahead of that. And what we can do here, for example, is we use, instead of a period behind a triple, we use a semicolon. And this semicolon usually indicates that subsequent RDF triples have the very same subject. So we provide a so-called predicate list below that. So here, for example, we can save to write the second time Pluto. We write simply that the semicolon behind Pluto has been discovered in 1930, and then continue with another predicate, or property here, which means the discoverer is Clyde Tombaugh. If I wanted to, for example, provide other facts about Pluto, then simply I would not close the triple behind Clyde Tombaugh with a period, but with a semicolon, and then simply add what is coming next. So you could probably also imagine that, for example, you do not want simply to repeat the subject, but also, let's say, you have the same subject, the same predicate, and then different objects. Therefore, RDF also provides something interesting. So if you don't use a period or a semicolon behind a triple, if you use a comma, this indicates that subsequent triples have the very same subject and property. So you provide a so-called property list. And here we see, for example, that Pluto has 3 satellites, which are called Hydra, Nix, and Charon. So here you see also in the upper part of the slide the graph representation of these facts that we are here referring to in RDF turtle serialization. So it's quite easy. You have 3 different building blocks. If you write everything in triples, simply close every triple by a period. If you are, for example, complementing facts about the same subject, use a semicolon. If you want to provide several objects for the same subject property combination, use a comma. So this is quite simple. Okay, next thing we should learn. For example, look at this example here. First, we look at the graph example. What we have here, we say, for example, that Pluto has a main radius, and this main radius then is a typed literal, which is expressed as a floating point number with double precision. So it's the same with the mean temperature, and then we have discovered, so the discovery day, it's a date, and then we have a label. The label is a string, and the string should be interpreted in English language. How do I write this in Turtle? Quite easy, as you see here. We have lots of facts about Pluto, which means we have here a predicate list that we add to the first triple we define here about the subject Pluto. Then we have all these properties, which all stem from the DBpedia ontology vocabulary. We will learn later on about that. And then there are the objects, which are all typed literals, so literals that have a data type. And in Turtle, simply you write the literal. You first write the literal as a character string in double quotes, and then you add the type information based on the XML schema data type that you want to use. But you can also write this XML schema data type, which is an entire URI. Of course, you can abbreviate this URI simply by, for example, defining a prefix for XML schema definition language that we have here. The prefix XSD comprises the prefix of exactly this namespace that should be used here. So the first three that you see here define different typed literals with the help of this abbreviated URI, which indicates the data type. The last one then is a character string, which should be interpreted in English language. So we simply write behind the character string in double quotes, we write then ampersand and the two-letter or two-character abbreviation for the language, which is in this case EN, which means English. So these are typed literals. But there is more in RDF. For example, the problem, how do I express so-called many-valued relations? Just have a look at the following problem. Pluto is visited by two different spaceships on two different dates. Let's have a look at the graph representation we have here. So we see here a spaceship which is called New Horizons. So we see Pluto, and then we have a space mission, New Horizon, and then we have a date visited, which is in 2015. And next we have a space mission, which is referring to the USS Enterprise from the well-known Star Trek series. And this has been visited then somewhere in the 23rd century. Okay, but the problem is, by a representation like that I read that this from top to the bottom was simply by chance. So there is no fixed order. It's not really clear what is the unique association between which date when Pluto has been visited by which space mission. So you can't do this with plain RDF. So you have to think about another construct how you represent multi-valued relations with RDF. So how should you do that? Just think a moment before I give you the solution. Well, the solution looks like that. You remember that we have introduced in the last part of the lecture so-called blank notes. And you might have wondered, for what reason do I need blank notes? So to identify something which exists and I do not have the identifier for it. So multi-valued relations here are a perfect example for the use of so-called blank notes. What I can do here, for example, I can define a blank note, which is the object here or the target of space mission that you see here. And then I say, okay, this target then is connected to a spaceship and a date visited. And therefore, I can associate a specific spaceship at a specific date to a space mission. This would be the graphical representation for that. So I introduced two new blank notes. First one for the New Horizon mission, second one for the Enterprise mission. The point is, these are anonymous blank notes, which means they are not referenceable, they don't have any idea. We only say there exists a space mission which comprises a spaceship and a visiting date. That's all. We do not say more about this kind of space mission. So blank notes can be introduced to represent multi-valued relationships. Of course, they can also be introduced for resources that don't need a name, so for so-called auxiliary nodes, and this is a typical case for auxiliary nodes. how do I do that in Turtle? Well, this is something new. Just have a look. What we have here, we have our prefix definitions, the usual stuff. We also have a base definition to make everything quite short. And then to represent this little graph where the subject is the blank node, I write the blank node simply here with this interesting square bracket. So these square brackets denote that this is a blank node. And you see here, this is a blank node which is connected then to two properties, spaceship and visited. And then, of course, as the object, you have the new horizon and you have the date in 2015. So this would be the way how you can, for example, define a so-called anonymous blank node. The blank node is anonymous because it does not have any ID and it cannot be referenced from outside. So this is a blank node. Okay, let's have a look at the entire construct here, because now it's getting a little bit more complicated. So here we have Pluto, and Pluto has been visited by space missions. And then we have two blank node constructs which come here. And you see here, to identify the entire blank node construct, the previous subject, which was the pair of these square brackets, now encloses the entire compound. So the object starts with a square, with an opening square bracket. Then you have property object, and this of course then is a property list. You have again a property and an object. And then when the construct closes, the square bracket closes, and then I have the next object in this object list. So here is the point where I use two nested anonymous blank nodes. So you see here, Turtle gives you a way also to write rather concise, or to use a rather concise representation of exactly this more or less complicated graph. So this is the use of blank nodes and how they are used in RDF. Now, it could be possible that within the same graph, in the same document, exactly this blank node, this space mission, might be of some importance, and I want to say something about it. I want to reference it. Within the same document, this is possible. How? There is a second version of so-called blank nodes, and these are the so-called dereferenceable blank nodes. I can assign a unique ID, unique within the document where this Turtle RDF is somehow written. I can define there a unique ID which is used exactly for this node, but this is not a URI. The point is, then this node can later be referenced within the same document, but it cannot be referenced from outside. So this is not a World Wide Web URI identifier. This is only for within the document. So let's have a look here at the Turtle document we have here. Of course, then we do not have to use square brackets. What we can do here is we can use the two IDs, and the referenceable blank nodes, these IDs, are characterized or denoted in Turtle by a leading underscore. We have the underscore, which denotes the namespace of these blank nodes. Then you have a colon, and then you have the idea or the ID of exactly that blank node. So which means Pluto has been visited by two space missions which have the ID ID1 and ID2. And then you define ID1 and say ID1 has a spaceship, New Horizons, and it has been visited in 2015, and so on and so on. So these are the so-called dereferenceable blank nodes. Keep in mind this is quite handy within a unique document, but you cannot use blank node identifiers from outside. So this is not possible. Okay, so much for now, but of course, there is more possible, or there are more possibilities in RDF, and we will see in the next lecture what else is possible to abbreviate or to make more complex constructs in RDF.